Okay, hello everyone, it's Salar and we are in part 41 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I talked about stack and queue, and I said these data structures don't have their specific implementation, and a stack implemented by singly linked list and queue implemented by a linked list or doubly linked list. Okay, but in this part I want to talk about another list, circular list, and another queue. Just like other list, circular list has its implementation in C. Okay, but circular queue, like queue and stack, implemented by a list, by circular list. In this time by circular list. But what's circular queue? Just like queue, circular list has some nodes. For example, here I have 8 nodes, and a node point to the next node and previous node. Okay, in each node we have a pointer to the next node and a pointer to previous node. But in circular list we don't have nil node anymore. Okay, we don't have nil node. But in each list we have a pointer to first node and a pointer to last node. Okay, and this list has a circular form, and the last node point to the next first node and first node point to the last node. Okay, here is a circular list, but let's see how I implemented this list. To implement the node, like before, we have a structure. Okay, we have a structure, circular list node. For each node we have a pointer to element, a key, a pointer to previous node, and a pointer to the next node. Okay, just like linked list or doubly linked list. But in the structure of the list, here another time for list I have a structure. In this time, like before, we have a size. We don't have nil node anymore. We have a pointer to first node, okay, and a pointer to last node. So let's see the repository of project. As you can see, in include I have circular list and circular queue. We get into circular queue in some minutes later, but in circular list I have a structure for node, element, key, pointer to previous node and pointer to next node. And for circular list we have size, first node and last node, pointer to first node and pointer to last node. Okay, here a pointer to first node and a pointer to last node, and a variable that saves the size of the list. Okay, like before, we have a function to create a node. We have a function to create a list. We can insert a node at the first of the list, at the last of the list, insert after another node. We can, for example, here we can insert node X after node Y, or insert before because of this previous node pointer. For example, and here for insert before we can put a node X before node Y or Y. Okay, we can delete first node in the list, delete that last node in the list. We can use this function to delete a node after another node. Okay, for example, in this list we can delete a node that is after node X, okay, or delete before, or delete any node that you want by using of X pointer. Okay, but there is another function, push index. we don't have push index in previous linked list and single linked list, but we have push index here. What is push index? As you can see, push index is an operation that push first node pointer and last node pointer ahead one step. For example, when your first node pointer point to 1 and last node pointer point to 8, if you use push index function, now after that the first node push to this node, the number 2, and last node point to this node, number 1. Push one step ahead, and it has some usage and sub-application to implement an real-time operating system. Okay, now let's see an example and use circular list to do an example in Eclipse. And here is example. If you want to use circular list, you need to add this header file in your code, circularlist.h. Okay, like before, I have some elements, string 1, string 2, and string 3. The value of string 1 is 1, 2 is 2, and 3 is 3 in a string. We have a list, circular list, pointer to list, and pointer to 3 nodes. Config board, but we don't need this config board in this example. And create list by calling this function, create list, create new list, circular list, create new list. And after that, create node 1 by using of this function, circular list, create new node, by using of this element string 1 pointer to element 1 and this key. And after that, insert this node at the end of the list, at the last of the list. Okay, put node 1, insert node 1, last of this list. Another time, create node 2, insert last, and for node 3, another time, create node and insert last. After that, use circular list push index to push first node and last node pointer ahead in your list. Okay, so let's debug this project. Okay, now I'm in debug perspective and I have my variables, my elements, list, and nodes. Okay, first I want to run my code until this line before calling push index. Okay, now as you can see in the list, I have size, and size is 3 because I've inserted 3 nodes in my list. First node is node 1. Okay, first I have inserted node 1. After that, I have inserted node 2 after node 1, and after that, insert node 3 after node 2. Okay, so after node 1 I have node 2, and after node 2 I have node 3, and for example previous node 2 I have node 1. Okay, but so as you can see here in my list, first node is 1. Okay, string 1 by key 1 with key 1. Okay, so now let's do run push index. Another time, see the list. The size is 3, but in this time, first node is node 2 because I have pushed the first node index. Okay, first node pointer, this pointer. Okay, and last node is node 1 in this time. In this time, last node is node 1. Okay, like here, first 1 is first node, but after push index 1 is last node. Okay, here is an example about circular list. But let's get back to the slides. After circular list, let's give some information, a little information about circular queue. Just like Q, circular queue doesn't have a specific implementation in C, and I've implemented circular queue, as you can see here. In include, I have circular queue. I've implemented circular queue by using of circular list node, circular list, circular queue node, circular list, circular queue. Like queue and stack, that they are implemented by other data structures. And like before, circular queue is a FIFO data structure, FIFO queue, okay, FIFO data structure, and implemented by circular list. But the difference is different than circular list. Instead of insert and delete, we have NQ and DQ. NQ, insert first, insert last, like Q, and DQ, delete from first of your list, just like Q. Here. Some definition to create node, create list, create queue, NQ, insert last, like before, DQ, delete first. And just like circular list, you can delete any node that you want by delete list or circular queue delete node, okay? Push index, like circular list, search by element, search by key, get size, head, first node in your list, and get next node after a node. For example, when you give node to this function return node dot next node, okay? And you can do any practice and example by this library, okay, but this header file. And I don't give you an example for circular queue because it's so easy for you. I know it's so easy for you. Okay, thank you very much. Thank you very much to see me, and see you soon in the next part.